All right, hello. So this lesson, we're going to continue working with proportional relationships, and we're going to actually learn how to write the equation for proportional relationships. So here we go. So there is a warm-up on the board. Does a graph represent a proportional relationship? How do you know? All right, so let's look at it. You should know because it goes through the origin, it is a proportional relationship. So any graph that goes through 0, 0 is proportional. So that answer is yes, and that's how we know. If you're understanding that, and that makes sense. All right, next. So here's what we're doing today. Essential question: how do I determine the equation for a proportional data for proportional data on a graph? Today I'm representing linear proportional situations in the form of y equals kx so that I can determine if an equation represents proportionality. I'll know I got it if I can assess a given equation and determine if it's proportional or not. All right, so proportional relationships, we put it all together now. So it is a relationship between two quantities in which the ratio of one quantity to the other is constant. Here is the equation, how it is represented. Y equals kx, where k is called the constant of proportionality. And you get the constant of proportionality by y over x. Okay, so look at this graph here. It is proportional because it goes through 0, 0, and then if it's got a constant proportionality because the change is the same, and that change is related to slope. But for the equation, we do y over x to get the k, and so we just look at this first point here, or you can look at any point and simplify. So y is 3, x is 1. So that would be 3 over 1 for k. And that does simplify to 3. So our equation for this proportional graph would be, let me just put that correctly. It's going to be 3x. Because you just write it just like this, y equals kx, our k is 3, simplified, so y equals 3x. That's what we're doing today. So putting it all together. All right, so just another example here. Actually, this is that same graph. I just went through this, so I didn't realize we had a separate slide here. So what is k? We just did that just to kind of go back up here. It's y over x. We used this point, and you can use any point. So that would be 3 over 1, which is 3. And so k is 3. Unit rate. So think about that question. What is unit rate? The unit rate, it's based on 1. So when this is 1, it's 3. So the unit rate is also 3. So it's the same if it's proportional. And so put it all together, we're going to use this equation, put in our k, and you use x. So the equation is y equals 3x. All right, so let's look at a couple examples here. So we have our equation written here, how to get the constant of proportionality. It says the graph below represents the total number of plants and the number of seed packets. So we know it's proportional because it goes through the origin here, 0, 0. So number of seed packets is here. It's 1 seed packet has 10 total plants. 2 would have 20. All right, so you can see that it is constant. What is that constant? And we can just go to our point here, and our point would be 110. So the constant of proportionality, remember, is k. And we do k is equal to y over x. So you could put that as 10 over 1, and that simplifies to 10. Unit rate based on 1, it is 10. Hopefully you're seeing the connection here. And then our question here, what what does the point 2, comma 20 represent? Okay, so that means there's 2 seed packets and we'd get 20 plants. All right, and then, so I'm going to add one more thing here. If I was set to write the equation, it's y equals 10x. All right, let's look at the next one. So this graph represents the total number of cups of coffee and total amount of sugar required to make the coffee. It's probably what mine would look like. So if you look at this scale down here, this is sugar in pounds. Oh, that's a lot of sugar though. 4 pounds for 20 cups of sugar, or 20 cups of coffee. Whoa, that's interesting. So we have this point here. We write it as 4, comma 20. And so we go back to, the K, the constant of proportionality is y over x. So my y value is 20, my x value is 4. So that would simplify to 5. So the constant of proportionality is 5. So if I had 1 on here, it would be at 5. So that is my unit rate. My equation is y equals 5x. And if we look at this question here, what does 1260 represent? It means that we would use 12 pounds of sugar for 60 cups of coffee. That is a really sweet cup of coffee. Okay, let's look at this one. So we've got 2 helicopters here. We've got helicopter A and B. So this is great practice plotting or coming up with the points here. So let's start with A and write these points. So this point is at 2. Now be careful with the scale, and then this is a 4, so in between would be 5. So you would write that as 2, comma 5. And the next one is at 4, comma 10. Okay, and I'm only going to do a couple. You can pause the video and do the rest. I want you to understand how to come up with these coordinates. All right, so B, let's look. We've got 3, comma 4. And then we have 6, comma 8. So if you look, they both are proportional. They start at 0, 0. So it goes through the origin. And it's a constant rate. All of it's the same. So what's the question here? So you're going to finish filling out the ordered pairs. What is K for A? So remember, back up here, y over x. So we can use any of the points. I'm just going to do 5 over 2. And that's it. So it does not simplify. And then for B, this first point, y over x would be 4 over 3. All right, what is the unit rate for each one? Okay, it is the same as the proportionality. Okay, so what that represents, this one represents, it can go 5 meters in 2 seconds. Okay, and if you wanted to do unit rate, you'd have to make sure you divide that, and this becomes 2.5 every second. This one doesn't come out as nice. It's like a repeating decimal, but so this would be the unit rate. Okay, the unit rate means per 1. So don't worry about B since it doesn't come out nice. But it would be like 1.3 repeating, or 1 1/3. You can write it as 1 1/3. Write the equation for each one. You have y, we've got our constant of proportionality here. So at helicopter A, y is equal to 5 over 2x. And then B, y is equal to 4/3 x. Okay, so, and just to recap again, for unit rate, you just have to simplify it for per 1, and these are just, comes out to decimal answers. All right, so describe the graphs. You would just say, well, helicopter A is definitely climbing faster than B because it's steeper. So this table shows the temperature of a fish tank during an experiment. Does the data show a proportional linear relationship? How do you know? So I want you to look at this right here. When x is 0, y is 82. Okay, that does not go through the origin. This would have to be a 0. So this is not proportional. The answer is no. So you can't write, that's why I just skipped that next part. You can't write the equation like that. We'll learn how to write equations for this type of problem later. Don't do it now. All right, so the last one that says amount Ava earns, Y, is proportional to the number of hours she works, X. So you can see that the Y is the earnings here. The X is the hours. So in 1 hour, she makes $5. In 2 hours, she makes $10. Write an equation to represent this relationship. Identify the meaning of proportionality and interpret its meaning. Okay, so lots of things there, but remember, you can just start, if I just use this point, and that point is 2, 10. My equation is y equals kx. Remember, k, to find k, it's just y over x. And so my y is 10, my x is 2. Simplify that, that's 5. So it would be y is equal to 5x. The constant of proportionality is 5. It is the slope again. If you go up 5, you go over 1. You go up 5, over 1. Up 5, over 1. So constant of proportionality is the slope, and this unit rate would also be this here, 5. So wrapping it up, you've got all these lessons on your schedule. Please make sure you're completing these, taking your assessments on time. Reach out to me if you have any questions.